Okay, let's start the session. So, welcome everyone. I hope you all are doing good. So, my name is Sambhav, and today we are gonna continue our discussion on statistics because in the last session we understood how to find the mean of group data using direct method, using assume mean method. In this session, we are going to talk about how to find mean using step deviation method, how to find the median of group data, how to find the mode of group data. I'm going to show you different examples also so that you can understand better how to approach in exam, how to approach the problems in the exams. So let's wait for 2-3 minutes so that everyone can join. I can see some of you are joining. So let's wait for 2-3 minutes so that everyone can join, and then we are going to start the session. In the meantime, you can let me know from where you are, how are you doing, you are doing good or not. Please let me know in the comment box. If you are having any doubt related to this session or regarding this chapter, you can ask us in the chat box or in the comment section also. So please do write your comments. Hello sir, hello, hi. So hello everyone, welcome. Yeah, please join the session. We are just waiting for 2-3 minutes so that everyone can join. Then we are gonna start. Yeah, hello, welcome. Yeah. The last time we just understood how to find the mean using direct method and assume mean method. Today we are gonna do how to find the mean using step deviation. So don't worry. Yeah. So now let's start the session. So last time we understood what is statistics, introduction and everything, correct? We understood how to find the mean. So there are basically three things that we are finding in this chapter, that is mean, mode and median. Three measures of central tendency, right? Now in this session, I'm going to show you how to find mean using step deviation, then how to find median of group data, then mode of group data, how to find it. So these three topics we are going to study today. Last time I showed you one table which is summarizing the whole chapter, na? This table, remember? So in this table, we are done with this mean of individual data, mean of ungrouped data, mean of group data using two methods. We are going to continue from here only because we are going to talk about mean of group data using step deviation method. Then we are going to see how to find mode and median also. Now let's continue. So direct method done, assume mean method done, step deviation. Why the name? See, deviation we have seen in case of assume mean method also, because we are calculating di there, no? So that is nothing but the deviation. But what is step deviation? Suppose if we are having a data which is having some large values, and even after calculating the di values, that is xi minus a, we are still having some larger values, then what to do? Then it will be a very lengthy calculation, no? So we are going to do one thing, we are going to divide that value, the di value xi minus a, by the class width. So if we are doing it, so there must be certain conditions where we can use the step deviation method, right? So when to use it? Class width is same. Whenever you can see that the class width is same, then you can apply step deviation. Numbers are very large. So number should be very large, then it is actually feasible. Otherwise, you are gonna waste your time. If numbers are not too large, the calculations are not gonna take that much time, then don't go with this method. Then go with other methods such as direct or assume mean method. But if the numbers are too large and the class widths are same, then this method is very helpful. I'm gonna show you using some examples. Okay, let's jump into the method now. So the formula that we will be using is x bar is equals to a plus summation fiui by summation fi into h. A little similar to assume mean method, but small changes. Now this is similar, that x bar is mean, a that the assumed mean that we are assuming is okay. Then what is this summation fiui? In assume mean method, we are finding summation fidi, no, the mean of deviation. Here we are gonna find the mean of ui values. Ui is what then? Ui is xi minus a by h, or in other language you can also say di by h. So h, what is h now? H is the class width. So class width we can find using the formula upper limit minus lower limit of class interval. This is very easy. You will understand this in I think in one example only. The second example you are gonna tell me how to solve it. Okay. Now, first example we are gonna consider like this. So here in this table we are given class intervals, we are given frequencies. Now, the class intervals are of uniform width, 0 to 50, 50 to 100, 100 to 150, right? So every class interval is having width equal as 50, correct? So now we can apply the step deviation method. The numbers are a little larger than the examples that we have seen in case of direct or assumed mean method. So here we can apply step deviation. Now, first thing first, as we have done in the case of assumed mean method or direct method, we are gonna find what? Class marks. So first I'm gonna create a table like this. So here we will be needing 3 more columns other than the given 2. So first one will be the same class interval, then frequency, then we need to find the class mark. We know how to find the class mark, right? Upper limit plus lower limit by 2. So 50 plus 0 by 2, 25. 1 second. I think I forgot to, yeah, 1 pen now. So 50 plus 0 by 2, 25. Then we have 100 plus 50 by 2, that is 150 by 2, 75. Then 150 plus 100 by 2, 125. Now 175, 225 and 270. How I am calculating this one? Very easily, because last time I told you a trick. If the class width is same, if the class interval is having same width, then you can directly add that much value to the previous class mark to find the next class mark, right? So here class width is same, 50. So I'm gonna add 50 to the previous value to find the next one. Now, after calculating the class marks, we are gonna assume one value to be our what? Assumed mean. So here, last time I told you that you can go with the middle value, right? But here we have 6 values. So there is no particular middle value in case of even number of values. So we cannot find a particular value that we can call as the middle value, right? So here we can go with any of the value, 125 or 175. I am choosing 175 as my assumed mean. So I'm gonna circle it and I'm gonna write A here, because we are gonna write A in front of assumed mean. Now this is my A value. Using this, I'm gonna find UI value. So first thing, the formula of UI, as I told you, is xi minus A by h. Xi, this particular value. A is a fixed value that we have assumed, 175. By h. H is the class width. So every class interval is having same width, 50. Now, 25 minus 75, xi minus a. 25 minus 75 will be minus 50. Divide by the h, that is 50. So minus 50 by 50, minus 1. Now let me ask you one thing. Suppose if we were using the assumed mean method, then we would be calculating di value, that is xi minus, correct? Then xi minus a would be minus 50. In the second case, it would be 75 minus 175. Oh, I did made a mistake here. 1 second. I did assume the value to be 25 minus 75. No, it is actually 175. My bad. So the first UI value would be 25 minus 175, that is 150, and then divided by 50 minus 3 then. In this case, 75 minus 175 minus 100 divided by 50 minus 2. 125 minus 175 is minus 50 divided by 50 minus 1. So usually it is gonna follow a certain pattern. Okay. Now then 0, because 175 minus 175, 225 minus 175, 50 by 50, 1. 275 minus 175, 100 divided by 50, 2. So usually it is gonna follow a certain pattern most of the time in a particular AP. Now here you can see the values, they are very small, -3, -2, -1, 0, 1 and 2, correct? If we would have calculated the values of di, then it would be around -50, -150, -100, -50, like that. So bigger than these values. So that's why we are using step deviation. We are even calculating, we are even creating values which are smaller in value, so that we can ease out our calculations. Now, after finding the values of ui, you are gonna do one thing. You are gonna find the value of fi and fi into ui, because in case of mean, we are usually finding the values in this way only. In direct method, fi xi. In step assume mean method, fi di. Here we are gonna find fi ui. So values of frequencies are written here. So 17 into -3, -51, 35 into -2, -70, then 43 into -1, -43. Then we have 40 into 0, 0 only, black hole. Now 21 into 2, oh sorry, 21 into 1, 21, and 24 into 2, 48. Now we are having all the values of fi ui, but still our work is not done, because we need to find what a value we are having. According to the formula, we must be having a plus summation fi ui. Summation means we need to add all these values, correct? Now find the sum of all these values. So I'm already having it. The sum is -95. This value is summation fi ui, and it is a negative value. So will our mean be a negative number? No, it will not be. Just wait. Now we need summation fi also. So we need to sum all these values. Summation fi would be around 180. Sum of all these values is 180. Now we are having everything that we need. A value, summation fi ui, summation fi, and h. H is fixed, no, 50. Now we are going to use our formula. So let me write down the formula. X bar is equals to a plus summation fi ui by summation fi into h. Value of a 175, the assumed mean. Summation fi ui minus 95. 95 it is, no? Yes. Summation fi 180 and into h 50. 0 and 0 can cancel each other. Now after calculating this value, it is coming out to be around 26.39, minus 26.39, because there is a negative sign, no, and we are gonna follow the sign rules. So one positive, one negative is gonna give me negative. So 175 and minus this value is 26.39. So after subtracting them, we are gonna left with 148.61. So this is your mean now. So even though we are getting the value of summation fi ui as a negative value, but still the mean, overall mean of the problem is absolutely positive, that is 148.61, because mean can be a value which is in between these values only, no? So 148.61 is in between 0 and 300. So this is how you are going to calculate the mean of group data using step deviation method. So the major advantage here is that we are reducing our calculations. We are reducing our calculation time. Even though we are gonna put some more time in creating this table, but if you are reducing your calculation error time, then you are gonna find the correct answer only. Okay. So yeah, thank you. So this method is very useful when the numbers are very large. Yes, absolutely correct. Now one more example. As I told you that after understanding the one example, you are going to tell me how to solve the second one. Okay, please help me in solving this. Again, we are given a table where we will be having some age groups and the number of workers. Now the class width is relatively smaller than the previous example, and the numbers are also smaller, but we are going to find the mean using step deviation here also. Now First thing first, what we need to do, we need to find what? Class marks. Absolutely correct. So class marks we can calculate using class intervals, upper limit plus lower limit by 2. So 24 plus 18. What is 24 plus 18? That will be 42, and by 2, 20. Then 30 plus 24 is 54, by 2, 27. Now I know the trick that the class interval is having same width, no, 6. So I'm gonna add 6 to previous value to find the next value. So that will be 33, 39, 45 and 51. Why I am able to use this trick? Because the class width is uniform. Then only you can apply this trick. Okay. Now we need to find the UI values. So UI will be xi minus a by h. So to find this value of UI, we must need to find first assume a value to be our mean out of these xi values. So there are 6 values. So with which value should I go with? I'm gonna go with 39 as my a. For this example, this is my a value. Now let's calculate the UI values. Xi means 21 minus 39, 18 by h. What is the class width? 6. So minus 18 by 6 minus 3. 27 minus 39 minus 12 by 6 minus 2. 33 minus 39 minus 6 by 6 minus 1. 39 minus 39, 0. 45 minus 39, 6 by 6, 1. 51 minus 39, 12 by 6, 2. So again we are having very small values, so we can easily calculate the next values, no? And what is the next value? That we need to find Fi UI. So Fi values, first Fi value is 6. 6 into minus 3, minus 18. Next value, 8 into minus 2, minus 16. 12 into minus 1, minus 12. 8 into 0, 0. Then 4 into 1, 4. And last 2 into 2, 4 again. Now, according to the formula, we need what? A value we are having. Then summation Fi UI. So let's find the sum. Here we are gonna write the summation Fi UI is equals to, okay, 4 and 4, 8. 8 minus 12 minus 4, minus 4 and minus 16 minus 20, minus 20 and minus 18 minus 38. So this is the sum we are having, minus 38. Now we need to find the value of summation Fi also, because we must be needing this, no, according to the formula. So what is summation Fi? So 6 plus 8, 14, plus 12, 26, plus 8, 34, plus 4, 38, plus 2, 40. So now we are having every value. A, summation Fi UI, summation Fi, and what is the value of h? 6. So now let's write down our formula. A plus summation Fi UI by summation Fi into h. Value of A is 39, the assumed mean, plus value of Fi UI is minus 39, minus 38, sorry. Then divided by summation Fi, that is 40. Fi values, the summation of Fi can never be a negative value, because we are finding the total number of frequency or total number of observations, and h is 6. Now 39, again we are having a negative value. So after calculating this, you are gonna end up with 5.70, but a negative value. And after finding the sum, your answer would be 33.30. So this is your mean. This is the mean of the given data set. This is the mean age now. So this value is lying in between these values only, in between 18 and 54. Yes, it is. It should be correct. Even though we are getting a negative FIUI value, but still we are finding the value of mean as a positive value, and it should be. So this is how you can calculate mean using step deviation method. So we are done with how to find the mean using different methods such as direct one or assume mean method and step deviation. When to use it, how to use them, I told you everything. So even if you are getting any confusion or you are getting any doubt, you can let us know in the chat box or in the comment section also. Yeah. Now let's talk about median. So in 9th class, if you remember, median is what? Median is that value which is at the center of the data set, or you can call it the middlemost value, right? But there is two things, that if we are talking about the middlemost value and in individual data set, like here, individual values where we are having, so it depends on how many number of observations are there. If we are having odd number of observations, then we can easily find the middlemost value, correct? Why? Because there we can apply the formula n plus 1 by 2, number of observations plus 1 by 2. That is easy. But suppose if we are having even number of observations, then there is no particular observation that we can call as the middlemost value, correct? Then we need to find the average of the two of the most middlemost values. Then we are gonna go with average of those two values. So here I have included both the examples. So first, here as you can see, we are having how many observations? 1, 2, 3, 4, 5. This is individual data set where we are having individual observations. 5 observations. Can I apply the formula directly? No, we cannot do that. To find the median of any data set, first you need to arrange the data set, if not in a particular order, either in ascending or in descending order. I am going with ascending order. So please arrange the data set. Lowest value is 2, then 3, then 7, then 9, and then 10. As I told you, if the number of observations are odd, then you can apply this formula. For odd, it is n plus 1 by 2. N is total number of observations. Here in this case, n is 5. So 5 plus 1 by 2 is 6 by 2, that is 3. So your third observation is your middlemost observation. 1, 2, 3. So third observation is 7. So the median of this data set or these individual observations is 7. See, here we are having only 5 observations. Then maybe you don't need the formula. You can directly find the middle value, no? Easy. But suppose if you are having 101 observations, then are you gonna count each observation? No, that will be very time killing, no? So you can apply the formula directly there, that is n plus 1 by 2. If you are having 101 observations, then the middlemost observation would be 101 plus 1, that is 102 divided by 2. 51st observation would be your middlemost observation. Now, if we are having even number of observations, then what? Because there we don't have any particular observation which we can call as the middlemost. So here, first thing first, we need to arrange the data. So I'm gonna do that in ascending order. So what is the smallest value? 4. Then we have 9. So usually if you get confused now, that if you are writing all the observations or not, do one thing. After writing 4, make a mark here. After writing 9, make a mark here, so that you will know that these observations you are done with. Then we have 10. Then we have 13, 15, and 20. Now we are having all the observations in ascending order. Now what? As there are even number of observations, so how to find the two middlemost observations? Here it is very easy, because the third and the fourth observations are the two middlemost observations. But is there any formula? Yes, there is. What is the formula? The formula is, first you are going to find the first observation by using the formula n by 2. Here n is even, First observation you can find using n by 2, and here is 6. 6 by 2 is third observation. Okay, circle it. Then n by 2 plus 1. For second observation, you can go with n by 2 plus 1. That is fourth observation, circle it. This is also very handy when the number of observations are too many. Then you can apply this formula. Now, as I told you that if you are having even number of observations in the data set, then you need to find the average of those two observations, the middlemost two. So how to find the average? You need to add them. 10 plus 13, that is 23, and divide by 2. 23 by 2 is gonna give us what? 11.5. So median of this data set is, okay, sorry, here we need to write the two middle values, no? So 10, 13, and here you can do the sum and find the average by 2, that is 11.5. So this is your median now. So there are two different approaches depending on the number of observations that you are having in your data set. This is only problematic when you are dealing with the individual data set. This is not a problem when you are dealing with a ungrouped data but with a frequency distribution table. Now here in this table we are given height of some students or maybe some guys, and okay, students only, because here it is written a number of students, and here it is written how many number of students are having that much height. Median again is the middlemost value, will always remain this only, the middlemost value. The median is always the middlemost value. Here we don't have the observations written in a particular order, correct? No, I mean to say that they are not written like an individual data set where each observation is written separately. Here we are given the frequency of each individual observation. It means 160 is there 12 times, 150 is there 8 times, 152 4 times, like this. Then we can do one thing. We can create a table like this. We are gonna again arrange the values in a particular order, like in this case we have arranged them in ascending order. So 150 first, 152 second, and then so on till 161. We are gonna write their respective frequencies here. Now we are gonna find the cumulative frequency of this data set. What is cumulative frequency? Suppose if I am having this data set, so what does this data set means? That first 8 observations are 150 only. In my data set, first 8 observations are 150 only. Then from 9th observation, I am starting with 152. So from 9th, 10th, 11th and 12th, these 4 observations are 152. Then from 13th, it is 154. Now, these are very small values, so I can directly count them in my head. But suppose if we are not having this much time, if we don't want to waste this much time, then how to find that which observation is starting from which position? So this you can know using cumulative frequency trick. What is or how to find cumulative frequency? The how to find is very easy. First thing first, you are gonna write the first observation as it is, 8, 8. First frequency you are gonna directly write as it is. Then you are gonna do one thing. You are gonna add this 8 with the next frequency. So 8 plus 4, so you can mark it like this, 12. Then you are gonna add 12 with next frequency 3, and you are gonna write this sum here, 15. 15 plus 7, 22. 22 plus 3, 25. 25 plus 12, 37. And 37 plus 4, 41. So there are total 41 observations. If you want to check, the last cumulative frequency should match the total number of observations. Let's see. 8 plus 4, 12 plus 3, 15 plus 7, 22 plus 3, 25 plus 7, 37 plus 4, 41. If they are matching, that you are finding correct CF or cumulative frequencies. Now, what to do now? Now you are having the total number of frequencies, that is 41. And as we know that the middlemost value will always be in the middle only, na? So out of 41, what is the middle observation? 41 by 2, correct? So we are going to divide this number. So that will be summation fi by 2. So here summation fi is 41 by 2. So it is 20.5. After finding this summation fi by 2, you are going to see where it is lying. Which value is nearer to 20.5. It can be equal to or it can be greater than in this column. So 22 is the value which is closer to 20.5. It is not equals to, but it is the nearest, closest and greater value than 20.5. So you are gonna mark this, circle this, and you are gonna look against which observation it is. So 155. So 155 is your median of this data set. This is very easy. First find the cumulative frequencies by adding the frequencies like this. Then you are going to find the summation fi, the sum of all the frequencies divided by 2. Whatever value you are getting, then you are going to look for that value in this column, cumulative frequency column. If it is matching exactly, well and good, then that is your median. If it is not matching exactly, like in this case, then you are going to look for the greater value than the value that you are getting here. It should be the next greater value. Like in this case, 22. You cannot go with 25, even though 25 is the value that is greater than 20.5, but still in between 20.5 and 25, there's one more value, that is 22. So we are going to consider this value to be our value that is going to tell us the median of this data set. So against this, the observation is 155. So the median of this data set is 155. Easy, correct? But the main part in this class is not finding the median of individual data or ungrouped data. It is basically finding the median of group data. In case of group data, it is a little bit challenging than these two. Little bit challenging, why I am saying? Because we need to apply a formula here. The formula is very easy. So first you need to remember the formula, then you can easily find the median of any group data. Let me show you. Median is again the middle value of any data set. So we are going to find the cumulative frequency. Now you understood the concept of cumulative frequency, how to find it, you know. So first we are going to find the cumulative frequency. Then we are going to look at the median class. What is median class? In this example, what we did? We calculated the cumulative frequency. We found the half of summation fi, correct? Then we are finding the median directly. In case of group data, we don't have individual observations written here. What do we have here then? Median class, class intervals, right? So whatever value we are getting after finding summation fi by 2, then against that, whatever median class we are having, whatever class interval we are having, we are gonna call it the median class. Why we are calling it the median class? Because our median will lie in between those values only. I will show you using an example, but that is our median class. Just understand this one thing now. Then we are going to apply this formula. The formula is L plus N by 2 minus CF by F into H. What are these values? L is nothing but the lower limit of the median class. Whichever class we are considering to be our median class, L value is the lower limit of that class interval. Now, N by 2 is what? N is the total number of frequency. So this is nothing but the summation fi by 2 value, same thing. N by 2 summation fi by 2, same thing. So this value we can easily find, minus CF. What is this CF? Is the CF of the median class? No. This CF value is of the class previous to the median class. Then F is the frequency of which class interval? The median class interval itself. And what is H then? H is the class width of class intervals, the difference between the class width, class interval, that is your H value. Now, it may be sounding confusing, no? But let me assure you that this is very easy. Let's consider one example. Here in this example, we need to find the median of the following data. So here we are given some class intervals, here we are given number of students. So 20 to 30, 30 to 40. So we are having a uniform class interval of 10 width, no? And the frequencies are not that much. So first thing that we need to do in case we need to find the median is what? Finding the cumulative frequency. We know how to find cumulative frequency. For that we need one more column like this. I'm gonna write the first frequency as it is. Then I'm gonna add this value with the next frequency. So 5 plus 15, 20. 20 plus 25, 45. 45 plus 20, 65. 65 plus 7, 72. 72 plus 8, 80. And 80 plus 10, 90. After finding all the cumulative frequency, I'm gonna match one thing, that the last cumulative frequency should match with the sum of all the frequencies. Let's see. 5 plus 15, 20. 20 plus 25, 45. Plus 20, 65. 72. 80 and 90. If they are matching, well and good. Now, the n value we are having now is 90, because n is nothing but the summation fi. So to find median, we need how many things? L we need, then n by 2 we need, then, and how to find the value of L? First we need to find the n by 2. Okay, let's do this. N by 2 means 90 by 2. That is 45. Is there any cumulative frequency which is matching with our n by 2 value? Yes, there is, 45. If this 45 is not there, suppose this value is 44 for now, then we need to go with this value, the next closest value. Okay, but in this case, this is directly matching, so we are gonna highlight this. This row we are gonna highlight. This is our model class now. I told you, no, whatever value you are getting as n by 2, based on that we are gonna find the model class. So this value is matching with this cumulative frequency. So against this one, this is our model class 40 to 50. So now what is our L? Model class is telling us that the value of mode will lie in between these two values only, 40 to 50. So if any value were to lie in between 40 to 50, we cannot consider the upper class limit. We can only consider lower class limit. So that's why in the formula it is given as L plus some other values, so that the final value should be in between 40 and 50. Correct? So now 40 is our L value. Then we need what? N by 2, 45 minus CF, cumulative frequency of the class previous to the model class. So the cumulative frequency of this model class is 45. The previous class cumulative frequency is 20. So this is my CF for the formula. Then we need divide by F, frequency of model class. So this is my frequency. And then we need what? H. H is nothing but the class width, that is 10 here. So we are having all the values. Let's calculate the final answer. First, let me write the formula. Median is equals to L plus n by 2 minus cumulative frequency of the previous class, then the model class, by frequency of the median class into class width. Okay, let's see. L value is 40. So I will write 40 here, plus n by 2 is 45 minus cumulative frequency of the previous class is 20 minus frequency of this class is 25 and class width was 10. Now 45 minus 20, 25. 25 by 25, 1. 1 into 10, 10 only. So the final value is 40 plus 10, that is 50. So median of this data set is 50. This value is here only, in between 40 to 50. So this is our final answer. Now let's consider one more example. Here in this example, we need to find the missing frequencies. in your final board exam, sometimes they will not ask you to directly find the median value, mode value. Sometimes they are gonna give you the median or mode value and you need to find the missing value in the table itself. So this is a little bit tricky, but the process will remain same. The formula will remain same. We are just gonna follow the reverse process now, or for some values we are gonna follow the reverse process. In this type of example, first thing, please don't fear these type of problems. We can easily solve them. They are easier than the normal median problems. So here, what is given to us? The class intervals are there, 0 to 10, 10 to 20, and so on till 50 to 60. Then in the next column, we are given number of students. So there are two values which are missing. You can see the question marks, no? So these are the missing values. We need to find them. And in the problem statement, what is given to us? N is equals to 100. It means the sum of all the frequencies is 100. And median is also given as 32. Okay, well and good then. I just need to apply the median formula. I need to put the value of median there. And whatever value I know in the formula, I will put them there. And whatever we are having as unknown, we can find it easily, right? This will be our approach. Now I'm going to consider one thing. I don't know these values. I will go with what? X and Y. I will consider these values to be X and Y for now. Now, after applying the formula of median, I should be having the values of X and Y, correct? How? First thing, we need to understand what is the median class here. See, to apply the formula, we must be knowing what is the median class, correct? Then only we can apply the formula. Last time, when we calculated the median, I told you that whenever we consider the cumulative half of the normal frequency, in this case, the 100 is given, 100 by 2 is 50, but still we don't know where is 50. So let's find the cumulative frequencies. Then this is X, this is Y. So cumulative frequency will be what? The first frequency as it is 10. Next frequency would be 10 plus X. You need to write it like this only. Then if you are adding 10 plus X with 25, so numerical values we can add. So it will become 35 plus X. 35 plus X plus 30, 65 plus X. 65 plus X plus Y. So two unknown variables. So 65 plus X plus Y. Then 65 plus X plus Y plus 10, 75 plus X plus Y. In the last example, I told you that this value should always match with the sum of all the frequencies. That is given as 100. So it means 75 plus X plus Y is equals to 100. So 75 plus X plus Y is equals to 100. From here, can we say that X plus Y value is 100 minus 75, that is 25. So this will be my equation number 1. Correct? Now, if we know this, we need to understand which one is the median class. Correct? Now, n by 2 value. Based on n by 2 value, we are finding the median class. No? Here n by 2 is 100 by 2, that is 50. But we are not sure where is 50. Correct? Then how to identify the median class? We can identify the median class here. Why? Because median itself is given to us, 32. If median is equals to 32, then this value is in between which class interval? In between 30 and 40, no? So this is our median class. If median is directly given to us, then in which two class interval, in which two values it is falling, that should be our median class. Now we know our median class, we can easily identify the values. So L is 30, then cumulative frequency of previous class is this one, 35 plus X, then frequency of this class interval is 30 and H is what? 10. We are having all the values. Now we are going to apply our formula. So median will be L plus n by 2 minus Cf by F into H. L value 30, right? Then n by 2 is 100 by 2 means 50 minus Cf. This is important because Cf is in terms of 35 plus x. It means there is one algebraic value x, no? So I'm gonna write this only 35 plus x. In bracket why I am doing, because here we are having negative sign, na? Then F, frequency of the median class. Median class is 30 into H means 10. Why? Because the class width is 10. Now, this 10, 0 and 0 can cancel each other. 30 plus, if I am opening the bracket, we need to distribute the negative sign on both the values. So, minus 35 minus x by 3, right? 50 minus 35, 15. So, this will be 30 plus 15, and I'm going to separate the values. 15 by 3 it is, and minus x by 3, correct? Median value we know already, 32. So I'm gonna write the value here, 32, 32. Now 15 by 3 is 5. 5 plus 30, 35. So this is gonna give us 32 is equals to 35 minus x by 3. I'm gonna do one thing. I'm gonna use this space now. I'm gonna do one thing. I'm gonna transpose this x by 3 to left hand side, so it will become positive, and this 32 to right hand side, and this will become negative. So x by 3 will be equals to 35 minus 32. So x by 3 is now 3. Therefore, value of x is 3 into 3, that is 9. Now we know one missing value, but we are having two values, no, as missing values. So how to find the other value? I told you, no, this equation that x plus y is 25. We know the value of x, we can easily find the value of y. So y will be 25 minus x, that is 9. So value of y is 16. So the missing values are 9 and 16. How to verify if we are getting correct answer or not? I'm gonna put the values here, x as 9 and y as 16. Okay, and I'm gonna see the sum. 10 plus 9, 19 plus 25, that will be 44 plus 30, 74 plus 16, 90 plus 10, 100. So this is matching with the total now. So it means we are getting correct answer. So this is how you can calculate the missing values. Median is already given. With the help of that value, we can easily identify the median class, and then our work is done because we can easily apply the formula after finding the cumulative frequencies, right? So this is how you can find the median of any group data, and if the median is given, then you know how to find the missing values also. So this type of problems you can expect in your final board exam, but you know how to solve them. Okay, now I'm gonna give you 2-minute break so that you can drink water or do anything, and I will be coming back in 2 minutes. So yeah, thank you. Then we are going to discuss about the mode of the group data. Okay, yeah. So I'm back again. So now we are going to talk about how to find the mode of group data. So mode, we know mode is what basically. Mode is that value which is being repeated the maximum number of times, or in simple language you can say the value which occurs most frequently, correct? So whichever observation is having the highest frequency should be our mode, correct? Yes, it is. That is the case when we are having ungrouped data or individual data, correct? But in case of group data, we don't know na which observation is repeated maximum number of times, because we are not dealing with individual observations here. We are having class intervals. So how to find the mode of group data then? We are having one formula. Mode of group data can be found using this formula, that is L plus F1 minus F0 divided by 2F1 minus 2 minus F0 minus F2 into H. Okay, what is this F1, F0, F2? First thing, we need to identify the model class. Like in the same way we did identify the median class, not using cumulative frequency, but there is the easier method to identify the model class. In this case, we are calling it the model class. After finding the model class, the lower limit of that model class is L, same like in case of median class. So the lower limit will be L. Then F1 will be the frequency of the model class. F0 will be the frequency of the class interval previous to the model class. Then F2 will be the class interval next to the model class. Then H is nothing but the class width. Why we are having 1, 0 and 2 written in subscript here? Consider it like a number line. So if 0 is here, 1 is here and 2 is here, no? Right? So we are considering model class to be at 1. So this is our model class. So just to remember the formula easily, we are creating the namings like this: F1 frequency of model class minus F0. So from F0 you will understand that we need to remember we need to look at the frequency of the class previous to the model class, correct? Because 0 is a number which is a preceding number than the 1, correct? Then F2, then we are talking about the class interval that is next. So we need to consider the frequency of the next class interval then. So that's why we are creating the formula like this: F1 minus F0 divided by 2F1 minus F0 minus F2 into H plus L also. L is the lower limit of the model class. Now, how to identify model class, correct? In case of individual data, whoever value is repeated maximum number of time is the mode. In case of ungrouped data, the observation that is having the highest frequency is the mode. How to identify model class here? Whichever class interval is having the highest frequency will be our model class. So here in this data set, you can see na different class intervals 0 to 20, 20 to 40, 40 to 60 and so on till 120 to 140. And their respective frequencies are written here. So whichever class interval is having the highest frequency is our model class. In this case, it is 60 to 80. So I'm gonna mark this. Okay, model class. So you can write. In your exam, you need to write everything. Which class interval is model class and why is that? Because this one is having the highest frequency. Then we need what? We need L value, that is nothing but the lower limit of this class interval model class. Then we need F1. F1 is the frequency of the model class, F1. Then we need F0 or F0, that is the frequency of the class interval before model class. F2 is the frequency of the class interval next to the model class, correct? Then H is nothing but the difference of the class intervals, so that is 20 here, class width. Now we know everything, so we are going to apply the formula. One second. So here we can apply the formula mod L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into H. Now one thing also you can observe here, when we are only subtracting F1 minus F0, then we are not multiplying F1 with any number, correct? Because we are subtracting only one value. When we are subtracting two values, then we are multiplying F1 with 2. So that's why in denominator it is 2F1 minus F0 minus F2. We know every value, correct? So let's put them here. So L is 60 plus F1 is 12, F1, F0, F2. F1 is 12 minus F0 is 10 divided by 2 into F1, that is 2 into 12, 24, minus F0, 10, minus F2, that is 6, and into H, H is 80 minus 60, that is 20. Now 60 as it is plus 12 minus 10, 2, divided by 24 minus 10, 14 minus 6, 8, into 20. So this we can do like this. So what are we left with? 60 plus 5, that is 65. So the mode of this data set is 65. So you just need to identify the model class, then you can easily apply the formula. After finding the model class, the frequency of that model class you can consider as F1. The frequency of the class interval before model class is F0, and the frequency of the class interval after the model class is F2. These value after finding, you will realize what is the value of L, the lower limit of the model class itself. Then H is nothing but the class width that you can find easily by subtracting the upper class limit and lower class limit, correct? Then formula you can apply is mod is equals to L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 and into H. This is your formula. Put the values, find the answer. Easy. This is the process when examiner is giving you a direct problem that please find the mode of this class or this data set, correct? But there can be some problems which will be like some values are given, some values are not given. Let me show you an example. This one. Here in this table, as you can see, class intervals are given, and in front of frequency or below frequency, you can see two values are written as X value. X, it means we don't know the exact value. Other frequencies we know. So can we judge which one is the model class here? No, we cannot. Not before finding the value of X. As of now, we may think that this is the model class, but we are not sure because we don't have the conclusive evidence, because we don't know these values. But the good thing is that the total frequency is given to us. In the statement itself, the total value of the sum of the total frequencies is given as 181, and both the missing values are equal. So we can do one thing, we can find the sum of all these values and then we can equate that with 181, and then from there we can find the one unknown value X, correct? That is what we are gonna do here. So let's find the sum of all the known values. So 15 plus 18 is 33 plus 30, 63 plus 50, 113 plus 48, 161, correct? And X plus X means 2X. So 2X plus 161 is equals to 181, right? From here, value of 2X will be 181 minus 161, that is 20. And then value of X is 10. Now we know the missing value or unknown value of X, that is 10. So for both the class intervals, it is 10 only. So I'm gonna do one thing. I'm gonna write 10 here, 10 here. Now we can find the model class easily because we know the frequency of all the class intervals, correct? So what is the model class here? Whichever class interval is having the highest frequency is our model class. So in this table, this is the highest frequency. So this is our model class. Now, after finding the model class, we need to write down every value. So either you can do it on table, but please don't disturb your table. You can write down every value here only. So L value is nothing but the lower limit of the model class, 13. Then we need F1 value, frequency of the model class, 50. Then we need F0, frequency of the class interval before model class, that is 30. We need F2, that is frequency of the class interval that is after model class, 48. And we need value of H, that is the class width, 15 minus 32. Only these values we need. So I'm gonna put the formula here. Mode is equals to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. So L 13 plus F1 50 minus F0 30. 2 into F1, 2 into 50, 100 minus 30 and minus, I guess it is 48, yeah. And H value is 2. Now 13 as it is plus 50 minus 30, 20 by 100 minus 30, 70 minus 48, 22 into 2. So 2 and 22 are divisible by 11. So 20 by 11 will be somewhere around 1.81. So the final value will be 13 plus 1.81, that is 14.81. So this is your mode now. So this is a very different example than the previous one because here we are having some missing values also. So first we need to calculate the missing values. How? Using the total number of frequency that is given to us already in the problem statement. Then we can easily identify the model class. Based on that, we can easily identify the values of the L, F1, F0, F2 and so on till H. Then we can apply the formula, that is L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Then we are able to find the final value, that is 14.81. So this is your mode now. So different examples, same approach. No need to panic in the exam. Even if the examiner is giving you a little bit tricky problem, no need to panic there. So please keep your calm. You can easily solve these problems. And we are done with all three measure of central tendency, that is mean of group data using direct method, assume mean method, step deviation method, and also the median of group data and mode of group data. So that's all about this chapter that we have covered in 2 sessions, and we did solve different problems so that you will get a clear idea about how you should be approaching the problems in the exam. Okay, so this is your table that I told you about. That this table is nothing but the summarized way of writing this whole chapter, right? So different type of data sets, different measure of central tendency. So this is how you can find the values. The formulas are written, the approaches are written. Okay. Now in this session we covered how to find the mean by step deviation method and median of group data and mode of group data. So that's all from our side in this chapter. And if you are having any doubt, you can let us know in the comment section also. Thank you for joining the live session. So for now, I will be taking your leave. Thank you. Bye bye.